Hello, namaste to all. Welcome to teluguoracle. Hope you're all doing well. I've been working with Oracle databases and ERP for more than 20 years now. I created this channel to share my knowledge, especially to the engineering students who get confused with the material and the pace in the classroom. This session is an introduction to the course, Database Management Systems, or what you call in your courseware, it's called DBMS. Please like, comment, share, and subscribe. Spread my channel so I can cover more topics on Oracle databases, ERP, reporting, AI, etc. So let's get into the agenda. So here is a short and sweet agenda for this introduction session. Let's discuss about database management systems, data, and what we're going to cover in the next episodes of our learning journey. Again, feel free to comment any doubts you have, or you can reach me at teluguoracle@gmail.com. I'll leave this email address in the description section. Thank you. So, what is data? What comes to your mind exactly when you think of word data? Yeah, everyone talks about data. What is data exactly? So I'd say you are an example of data. If you think a minute and understand this, your height, weight, color, education, mobile number, Aadhar number, everything about you and around you is a potential data point. So you can define data as anything that represent information, right? So what forms can the data exist? It can exist in many forms, from simple drawings to complex um, data structures or complex data. So you can have anything basically. But mainly you can classify in main forms. It can exist in such as plain text. It can exist as a form of image, audio. Listen to music a lot, I guess. So it's audio, and of course you videos. Yeah. So all these forms you are experiencing now, if you think, because this is you can see some text there, and these are I put in some images and there for you. So yeah, I'll go through these images, what this means exactly. And you are listening to my audio and my voice, and this entire thing is in a YouTube video, right? So this is an example of data in all forms, basically. Yeah, all common forms. Let's say not all forms, but common forms. But why? Why do you need this data? So what happens if we don't have data? So let's say in the world we don't have data, then what happens? So if you look at the right side picture, this one, like the evolution of man. So the more data we have, then humans could make more valuable decisions. Sometimes they were also wrong. Okay, you can always agree, but majority of the time, the availability of data and it resulted in many inventions which bettered human life, which improved human life, human values, and everything. Yeah, you might agree, totally agree, partly agree, but data in actually it helps. Yeah, it helps making analysis and making judgments, making informed decisions, take informed decisions, the right decisions. Okay? So if you look at these pictures here, so first picture, I would ask you, this is like a quiz question for this exercise. I would ask you to go and check what is this. Yeah. So this is one of the cave painting. Cave painting. This was made in 5th century BC, somewhere in central India, and this is one of the most famous paintings in India. And yeah, this was made 5th century BC, before Christ, and it it is, luckily it is still preserved there. So it is still there. So from that, what do you understand? What data that gives us? So it tells us how the 5th century, what were the how what were the lives of people in 5th century. So how, but at the same time, it makes you curious. How did they get those colors in 5th century? Where did they get those colors from? And they were so artistic. Then what you can create now? How is that even possible? First of all, how did they enter that cave? How did they make that cave? So all these questions. So you learned about history because of one such picture, right? So this is data. So it makes you think. It makes you analyze. So it makes you understand the lives of 5th century people. Yeah. And the second picture is this is most of you might have heard of. This is like palm leaf manuscripts, or in some languages we call Thalapatra Grandam. Yeah. So these are like the passed down wealth of knowledge from Vedas, Itihasas. Yeah. Um, some of these are preserved. They're still in some of the libraries in India and everywhere in the world. So very precious. So this is some kind of data. So without that, like we wouldn't have any books, Ramayana books or something like that. So this knowledge is passed on generations or two generations. So this is another form of data, right? And then the third picture. So this is the invention of printing press, yeah, which basically revolutionized distribution of data and knowledge. So it enabled more people to read, learn, discover, and further invent. Yeah. And then the last one, it's computer. The invention of computer, yeah, in the 20th century enabled data processing, collection, collection of data, reporting data, and analysis to make decisions that improve lives of people. Yeah. So this is the reason why I say, if you look at each picture, each of that is data, right? That in some other form we are capturing data, managing data, processing data, analyzing data, and making future decisions, understanding past decisions or past ancient people's lives. So this is data. So this is wealth, right? It is wealth which will be passed to future generations. So this is why I say, like, information is wealth. Okay, let's discuss about types of data. So broadly, we can say the data can be classified into two types. This one is structured data, and the second one is unstructured data. So as you can see in the top, so I put in the student details. The simple student details. You can add more columns there, but this is an example of structured data where data can be put in into tables with rows and columns. It's a predefined format. And the second example I've given here, it's a picture. So that picture can be anything. There's no definition that it has to be a specific data type or it has to be these many characters and all that. So that's unstructured data. Yeah. And second difference is storage. So this will be stored, the structured data, it can be stored in a relational database. Yeah. And of course, you can store part of unstructured data as well in relational database, but I'll come back to that when we go into detail of the data types. Yeah, but mostly this is unstructured data because it's huge amount of data. So it is stored in data lakes, object storage, file systems. Yeah. So, and it needs, even if you want to store it in relational database, if you want to store unstructured data in relational database, it needs complex data type, not simple data types. Yeah. And then schema. What is schema? So schema is basically, it describes the way the data is organized and the way relationships between data is managed. So structured data will have a fixed schema. So for this table, I'm going to say student number is a number, student name is a character, and email is a character, and with a at the rate in it. Yeah, that's the schema. Whereas unstructured data has no schema, so it is flexible. It has a schema, but it's not a fixed schema. It's a flexible. Yeah. One example of this is MongoDB. You can explore more. You can search. We'll discuss in the future videos. Yeah. And query language. How do you query this data? How do you update this data? How do you make analysis on this data? So on structured data, you can use SQL, structured query language. Yeah, and interesting part is you can also do the same thing on unstructured data, but you will need special tools. So this is where it gets interesting. So artificial intelligence, natural language processing, machine learning, all these provide special tools to deal with unstructured data more efficiently. Yeah, and some examples of structured data is employee records, sales transactions, the loads actually. So if you take any ERP system, for example, your university student management system. So you have student table, staff table, courses table, your buildings table. So all are defined in one schema, and there is a relation between these two, all of these, etc. That's a very good example of a relational data, how it's linked, etc. And unstructured data is like if you're using this, if you're commenting on my YouTube post, and all of that is unstructured. So you can add any comments, you can upload something, you can upload a document, you can and then you can put on any image. So all of this is unstructured data. Yeah. So we can go, we can discuss these when we get into the details of the databases, etc. So processing tools, use cases, ease of analysis. I don't want to confuse you just right now because it's just an introduction session. So yeah, well, when we get to that, um, when we get to that, we'll discuss. Yeah, thank you. Now that we know a bit about data, let's discuss what exactly is DBMS. Yeah, or database management system. So it is basically a system. What is a system? It's just a group of tools and processes that work together to achieve an objective. We are talking about computer systems here. So when you say a database or DBMS, so it has two parts to it. One is hardware. Of course, you need hardware to store your data, and another is software. So it is a software system. So what does it do? What does this software system do? It manages. And what does it manage? Whom does it manage? It manages data. Okay. Now, if I summarize what I just said, DBMS is nothing but a software system that manages data, right? Just manages data. You might ask, the definition is okay, I can put this in my exam. That's for theory questions, but why do I need it? Okay, let's take it with an example. Okay. You know Aadhar data. So everyone has Aadhar card. They provide, it's very important. And what happens to it once it is collected? So you go to your post office, you provide the data, you fill the form, and then the operator will take your fingerprints, your iris. Then what happens? What happens to your data? Because uh, it's very secure. It's your personal data. So what happens to it? So as soon as it's collected, it is processed, right? So once it is processed and you got enrolled, you have another card, then it's yeah, the data is there in the other database. So at the point of collection, it is stored or created in a database. Then let's say after 3 months, you move to a different place, your address has changed. So you want to go and change your address. You go there, you fill another form, and then change your address. Then your data is getting updated. Yeah. Delete in other scenario, it's not possible. You can make it not available to public. That is possible, but you can't delete it. Then and in regular databases, like say enterprise databases, order information or let's say sales information, yeah, or your customer information, these can be deleted in an enterprise database, yeah, because you have um, more access, etc. to it. So, and then it is secured. So, can I access your other details online through web? Can I go to Google or ChatGPT, just search for your Aadhar? No. Why? Because it is secured. So, it is who does all this? Creating data, updating, securing, managing data. It is all done by this system called DBMS. And how is that useful for me or you as a user? Because you will access your data or manage data through it. So you are filling a form on the web and say like, okay, create. You fill a new customer information in a sales form and you click on create customer. It will DBMS will process take that data. It will create that customer in the database or within the application. You use the DBMS. So application has direct access to the DBMS. Yeah, one example is the student information system. For example, it will display, let's say it will display all the student information and you will be able to update it. Yeah, you update it and that update will be sent to the database. So that is also DBMS. Yeah. So a simple example of DBMS can be just an Excel sheet where you update it. But more complex ones can be it's relational databases or NoSQL databases, which are far more advanced now, cloud databases, etc. So which we will cover in the next slide, how the DBMS evolution has taken place. Yeah. So for quiz for this one is which database Aadhar uses. I'll post this in the description. So it'll be try to find out which database Aadhar uses and why. Yeah. So the DBMS systems didn't arrive overnight. They have evolved. Yeah. So let's discuss the evolution from the 20th century, which is from 1900s. So after the printing invention of the printing press and the mass production of data, so this is the data was typically uh, written or printed on paper because you had printing press. You can print as many copies of data as you can and store the information in physical files or filing cabinets. This we even do even today. We do even today. Some important documents like your mark sheets, you print them, laminate, and store them in a file and forget about them. Yeah. So yeah, I'm just joking. It's just they're very important, and these are yeah. This is earliest you can say one of the DBMS database management systems. And then 1950s, 60s, when the invention of computers and then operating systems happened, the data was simply stored in text files. So you have a notepad now. If you correlate to a notepad in Windows, so that's just a text file. You just open it up, put some data in, and then store it. It need not be in any format. Just put some data in, store it. But each file has no relation unless you name it like this is student file, this is customer file. But there's no direct relation or you can't make a correlation between each files. Yeah. But it it provided a way to store your data. Yeah. And 1970s, which is when the landmark invention in databases by Edgar Cord, it made it feasible to store the data in a database with a relationship between different entities. Suppose you have the university, you have students, you have courses, you have course enrollment, you have professors or instructors. All these are entities and each are related, right? So when you put in student database, you can say which student can take what courses. So year one has specific courses, year two has specific courses like that. Yeah. And best example of this relational database, there are many. Uh, I'm I would choose Oracle because I worked on Oracle and I worked on it for a long time. And then comes 2000s, yeah, 2000, year 2000. From then on, the relational databases cater to structured data more, like you need to have a specified schema, specific schema, data in rows and columns, but with the need to store and process unstructured data, such as images, documents, etc. Also to handle the volumes of internet the data has brought. The new kind of database that will improve scalability and more dynamic was required. Then this um, new concept of NoSQL has arrived. Yeah, this which caters more to unstructured data, storing and processing of unstructured data. And then 2010, that is when cloud computing really picked up, and people thought, okay, why not database in cloud? So it's instead of having physical server in your basement, in company's basement, so why not in the database in cloud in a managed service with a managed services provider? Then it it is lesser for maintenance and easier scalability. And to add resources also, it is far more efficient than having a physical server in your basement and get a new physical server and increase the capacity. Yeah, so we'll discuss more about this when we get to the cloud computing sessions. But for now, just remember cloud computing enabled to move databases to the cloud. 2020, which is the current era, which we are now, this is the future of databases, is basically AI and automation usage, more AI usage, more automation. So databases to become more autonomous, that is managing themselves. Like you database can scale up, scale down, depending on the usage. If they have a breakdown, they tend to fix themselves looking at the repository. So all those things. So one example, couple of examples is this Oracle ATP. It has autonomous transaction processing, or ADW, which is autonomous data warehouse. So both of these are examples of autonomous databases. There are many. I'm just quoting Oracle's examples here. Thought that's enough to take home for introduction session. In the next episode, let's discuss relational database concepts, mainly normalization. We'll go through with an example, and data types in Oracle. Yeah. So these are relation concepts of relational databases and normalization. These are very basic foundations. Uh, it's better you understand these because you will come across this in your entire career, and it's very important because it helps you understand the databases or data models quicker, and let's say how to draw an entity relationship diagram and all that. Yeah, please comment any questions you have on the topic and I will respond. Please like, comment, share, and subscribe to the channel and spread the word. It encourages us to make more videos for your learning journey. Also, I'll leave some notes and quiz as I discussed in the description section. So yeah, you can respond with answers in the comment section. Yeah. Until then, let's discuss the new topic in the new episode. Until then, learn well and be curious. Thank you.